Hi, let's talk about homework 1, problem 5. The problem 5 is suppose 100 people are waiting for a blood test for a kind of disease. The probability is that for one person, the test results is positive equals 0.1. There's two test methods as follows. Method 1, test each person one by one. Then we have to do 100 tests. Method 2, divide 100 people into 10 groups with 10 people in each group. Then mix 10 people's blood and test that mixture. If the result is negative, then everyone in this group is negative. If the result is positive, then we test these 10 people's blood one by one. Now the number of tests becomes 1 plus 10 equals 11. And the question is, on the average, what is the number of the tests we need to do by the second method? So according to the problem, we can get the formula is 1 times probability k equals 1 plus 11 times probability k equals 11, which equals to probability all 10 people are negative plus 11 times probability not all 10 people are negative, which equals to 0.9 to the power of 10 plus 11 times 1 minus 0.9 to the power of 10, which equals to 7.513. Then for 100 people, the average number of tests equals to approximately 10 times 7.513, which almost equal to 75. So by second method, we can save about 25 tests. So according to this homework problem, I also found a similar problem on the website. The problem is it's sometimes necessary to give blood tests to a large population, say of n people. Here are two possible strategies for tests. First strategy is to simply administer two tests to each of the n individuals. The second strategy is to group the individual in group of k individual, whereas 1 smaller than k smaller equals to n, and to pool their blood samples together and test this pooled sample. If this pooled sample tests negative, this one test suffers to the k people. If the test of the pool people blood is positive, then each of those k individuals is tested separately. Also, altogether k plus 1 tests are required for the k people. So it's like the same question as the homework problem. And also the problem B in this picture is what's the expected value of number x of tests necessary under strategy number 2. So it shows we can get the n divided the k groups of k individual, and then they get k plus 1 times 1 minus 1 minus of the power k plus 1 times 1 minus p of the power of k. So then for the whole group of n, we get the n divided k, and then k plus 1 times 1 minus p power of k plus 1 times 1 minus p of the power of k. And then they get ex equals m divided k times k plus 1 times 1 minus p of the power of k, and plus 1 times 1 minus p of the power of k.